Comes out of 2.7, implicit differentiation. This question is somewhat similar to the last. We're given some very unusual equation relating x and y together, and it's not solved for y, nor is it immediately obvious how you would solve it for y, and so I don't solve for y. I might change this radical to an exponent, but what I need to do is differentiate everything with respect to x, so take the derivative of all of this with respect to x, meaning that, what do I have? The first term is going to be 6x squared plus, now the derivative of 4y to the 1/2 is going to be 2y to the negative 1/2 times the derivative of y with respect to x. Sometimes use y prime, sometimes use dy by dx, but perfectly acceptable either way in this case. X cubed times y cubed requires product rule. So I gotta say, well, what's x cubed times the derivative of y cubed? So 3y squared times dy by dx plus y cubed times the derivative of x cubed, which is just 3x squared, plus 0 because the derivative of 7 of a constant is 0. So we ran into this situation before where we have two dy by dx, or in the last case situation it was 2y primes. Our job here is to get all those y primes to one side, or dy by dx is to one side in this question, so 2y to the negative 1/2 dy by dx minus x cubed, might as well put the 3 here, 3x cubed y squared dy by dx equals 3x squared y cubed minus 6x squared. The reason why that's a good step is because then you solve for the dy by dx by factoring it out as a common factor. So I've got 2y to the negative 1/2 minus 3x cubed y squared equals, and I don't do much on this side. You could start factoring now or leave all the factoring till the end. So you've got this, meaning that you can say dy by dx equals 3x squared y cubed minus 6x squared, all divided by 2y to the negative 1/2 minus 3x cubed y squared. If this was a question where they're saying I'll find the slope of the tangent line when x is this and y is this, then we could just put in x and y right now and not go any further with it. But in this case we do need to take it a little bit further to simplify the factor and make it look a little bit nicer. On the top we have a simple common factor of 3x squared, leaving us with y cubed minus 3. On the bottom, a little bit tougher, but I do have this y term. Y to the negative 1/2 would be the lowest exponent on any of the y's, leaves me with 2 minus 3x cubed times y to the, now this is the tricky part, 5 over 2. Radicals always seem to result in some awful stuff happening in your final answer. And finally, the last answer, you'd be very unlikely to leave that y to the negative 1/2 in the denominator. You'd probably write that as 3x squared y to the 1/2 times y cubed minus 3, all of that divided by 2 minus 3x cubed times y to the 5 over 2. And equivalent but simplified expression for that derivative. And again, dy by dx, totally equivalent to y prime. If you decide to use y primes instead, sometimes these things look a little bit neater and tidier.